Good? All right, welcome to your last day of chemistry class for the semester. Just one cheer? Okay, that's kind of surprising. There we go. Well, maybe that just means that you really loved the course and enjoyed everything about it, right? So, just a reminder, we've got course evaluations up right now. We really appreciate your feedback on the course. For both here in lecture, for me and Calvin for recitations, and for your lab TAs as well, so that we can see how everyone's been doing and get some feedback on how to improve things for the future. So, all right, we're going to start off with the same question from last lecture, just as a little refresher. So remember that we got down to the fact that this is a heptane, and that we have two methyl groups. And so the question that I left you with is, do you think that we're going to label it 2-methyl-4-methyl, or do you think it's going to be 2,4-dimethyl? And I gave people the hint that remember that chemists are lazy. So, is it not polling? Try that again.
It's like he doesn't miss any, even like the small ones.
There we go. I don't know what I did, but I magically fixed it. So, go ahead and put in your answers.
So there's like something that takes like a credit for like different grades.
All right, 98%, very nice. So, these names can get rather crazy and long, you can imagine, with all the different groups that can come off of our backbone. So we like to kind of condense those where we can. So if we have two of the same group, for instance, two methyl groups, then we're going to call that a dimethyl instead of writing methyl twice. Okay, so we talked about the difference between alkanes and alkenes on Wednesday. And we also went on to how we name our alkane compounds. So now we're going to move on to how we name our alkenes. And the good news is that it's going to be pretty similar. We just want to make sure that we know where everything is, including the double bond for our alkenes. So for our alkenes, again, we're going to find that longest continuous chain, but this time we want to make sure that the chain includes the double bond, because that's what makes the compound our alkene. So if we look here, when we're counting our 1, 2, 3, 4, 5 carbons, each peak is a carbon, each end of a line is a carbon. So we know from our naming rules that that's going to be a pent. And then we're going to show where that double bond is on our molecule, because where that double bond falls can actually change the properties of our molecule. So we like the lowest numbers, we like low numbers. So if we start with a 1 over here, we're going to be able to get a 2 and a 3 for our double bond. So we can put that name in front of the pent. So 2 to indicate where the double bond is, and then a hyphen always follows our numbers. And then we're going to end in the root ene for our alkene, ene. So this is 2-pentene. Okay, so let's look at some other examples. So for instance, if we look at the first one, again, 1, 2, 3, 4, 5 carbons, but notice now that we moved our double bond. So while this is still a pentene, we now have to call this one pentene because our double bond starts at that first carbon in our chain. So how many carbons do you guys see in the middle one? 4. Anyone remember what 4 was? What the root is for that one? Bute. Nice. All right. Remembering from Wednesday. Okay, so this is butene. What number do you think is going to indicate the double bond? It's a good guess. 2. So if we start with our number 1 here, this becomes number 2. But notice it's actually the same over here as well. 1, and that would become 2. What about the next one? How many carbons do you see? 3. What's our root for 3? You want to remember? Prop. Like propane. So this is propene. Now that we've got that double bond. But we don't actually use a number on this one. Because notice that if our double bond were on our other carbons, it would look exactly the same as where the double bond is right now. So if it's redundant, you don't have to put the number. And that's going to happen with very small molecules like propene or ethene. So for larger molecules, though, starting with butene and going on up, your double bond can be in multiple positions, so you got to say where it is. All right, so ready for practice? How many carbons do you see in the longest chain for this alkene? So we have to include the double bond, right? So let's start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our longest chain. Let's go ahead and so what is our root going to be for 10 carbons? How are we looking on the dot cam? Very zoomed out. Now I'm going to put it on the left for a second so I can actually see what I'm doing. All right, what have we got for 10? There. All right, so we've got dec. What do you think the ending is going to be? Are we an ane or an ene? Ene, okay. So we've got decene. And then if we look at our numbering, we can see that we started up here to give the small numbers for that. So that would be our 2-decene. Do you think we're done with our name? No, what else do we have there? I see some other groups off the end. Do you guys remember what this is called when we don't have the straight chain? What was the other one called? Starts with a B, branched. Branch. So we've got some branches that we need to name. So what does this one look like to you? How many carbons are in this branch? And what was our prefix for that one? Meth. So this is a methyl group. How about this one? How many carbons do you see? So what's that group going to be? Propyl. And we've already done our numbering. So we've got 8-methyl-4-propyl 2-decene. See how the names start getting pretty long when you start adding a lot of stuff to them? Okay, so the 2 is showing us where our double bond is showing up. That is always going to come right before the parent name. So the number for the double bond comes right before your decene in this case, all right? How about this one? Your turn. How many carbons do you guys see? We'll have narrowed down the choices a little. I count 5. Everyone else count 5? Do you like my numbering scheme or should we flip it? Flip it. Sorry, I can't hear you. Yes, but in this case with the pentene, so anything butene or larger, there's multiple positions where you could have that double bond. So that double bond could be on the first carbon instead of the second carbon, so we need to identify where it is. All right.